Welcome, my friends. In this video, I'll be introducing the graphs of sine and cosine. Let's start with the graph of y is equal to sine of x, which we're going to graph using the unit circle. Now, one possible point of confusion that you might have to get past is that the y and the x in y is equal to sine of x do not refer to points on the unit circle. We've talked about in the past how on a unit circle, the x-coordinate is cosine of theta and the y-coordinate is sine of theta. That's not what we're talking about here when we say that we're graphing y is equal to sine of x. X is actually the angle that you would be inputting into sine, like pi over 6 or pi over 4, etc. Well, if that's the case, why don't we just say that we're graphing y is equal to sine of theta? Well, traditionally our coordinate system is in terms of x and y, and x is the input and y is the output. So in this case, the input is going to be the angle, which we have been calling in the past theta, but here we will be calling it x. And the output will be y. One other thing to note is that the graphs of trigonometric functions are typically only shown in radians. You could graph them in degrees, but it's much more common to use radians. With those caveats out of the way, let's graph y is equal to sine of x. Our input will be an angle, and our output will be some point on the unit circle, specifically the y-coordinate, because sine is the y-coordinate on the unit circle. Let's start with sine of 0. We know that sine of 0 radians is equal to 0, because that is the y-coordinate on the unit circle, so we can plot that point onto the graph. If we input pi over 2 into sine, we will get 1 out, because that is the y-coordinate on the unit circle. Therefore, sine of pi over 2 is 1, so we will have the point pi over 2, 1 on the graph. At pi, the y-coordinate is 0, so that means that sine of pi is equal to 0, and we will have the point pi, 0 on the graph. At 3 pi over 2, we are at the point -1 in terms of y, so sine of 3 pi over 2 is equal to -1. That means the point 3 pi over 2, -1 is on the graph. Finally, at 2 pi, we are all the way around the circle, and the y-coordinate is going to be 0, so sine of 2 pi is going to be equal to 0. That means we have the point 2 pi, 0 on the graph. If we connect the dots, we will have the graph of y is equal to sine of x. Now this is only the graph of y equals sine of x for one rotation of the circle. Of course, we could have angles that are larger than 2 pi or less than 0. This is what we call one period of the y equals sine of x graph. The graph will continue to repeat itself over and over and over for larger or smaller angles, but this is only the first period for y equals sine of x, or one rotation of the circle. Let's talk a little bit more about the graph of y equals sine of x. I think of the graph of sine as starting at 0, 0 and increasing from there. Now, of course, since we can have negative angles, the graph doesn't literally start at 0, 0, but we have to start our graph somewhere, so a convenient place to start drawing it would be at 0, 0. From 0, 0, we increase from there until we get to pi over 2, at which point we will be at our maximum of 1. From there, we decrease until we get to pi, at which point we will have a 0. From pi, we continue to decrease until we get to our minimum of -1 at 3 pi over 2. And then we increase back to 0 at 2 pi, and we continue the cycle over and over and over again. Trigonometric functions are cyclical, meaning that they repeat themselves every so often. The frequency with which a trigonometric function repeats itself is what is called the period. In the case of sine, the period is 2 pi, as the graph repeats itself every 2 pi radians. So here, after 2 pi radians, the graph will just repeat what it's already done. So it will increase to a maximum, decrease all the way back down to a minimum of -1, and then come back right where it started. And every 2 pi radians, it will repeat that cycle. The domain is a general term for all of the allowable inputs into a function. In other words, which x values are allowed in the function. For sine of x, the domain is all real numbers, meaning anything from -infinity up to +infinity can be plugged into sine. The range is the general term for the possible outputs of the function, or the possible y values. In the case of sine, the range is from -1 to 1 inclusive, which we indicate by square braces. The lowest value you can get out is -1, and the largest value you can get out is +1. The amplitude is a term that refers to how far the function travels from its center, which is called the midline. In the untransformed sine function, the midline would be the x-axis. So the distance that we travel from the midline of the x-axis is just 1 unit. We either go 1 unit above or 1 unit below, which means that the amplitude of sine of x is just 1. In order to graph y equals sine of x, we used a number of key points. The points that we used were 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. In general, on a trigonometric function, there will be key points at every quarter of the period. In this case, 1/4 of the period of 2 pi is just pi over 2. So at every pi over 2 radians, we have another key point. This will be an important thing to remember as we graph translations of sine. In addition to these key points, I would remember that sine starts at 0, 0 and increases from there. That will be helpful to remember as we graph translations of sine. Let's graph y equals cosine of x. X will be the input of some angle on the unit circle, and y will be the output, which is the x-coordinate on the unit circle, since cosine represents the x-coordinate. For example, cosine of 0 radians is the x-coordinate of 1, so that means that the point 0, 1 will be on the graph. Cosine of pi over 2 is going to be the x-coordinate of 0, so that means that the point pi over 2, 0 will be on the graph. Cosine of pi is equal to negative 1, because that is the x-coordinate, so that means that the point pi, negative 1 will be on the graph. At 3 pi over 2, the x-coordinate is 0, so cosine of 3 pi over 2 is 0, and the point 3 pi over 2, 0 is on the graph. At 2 pi, we're back where we started, and the x-coordinate will be 1, so cosine of 2 pi is equal to 1, and the point 2 pi, 1 will be on the graph. Connecting the dots in a smooth pattern, here is the graph of y equals cosine of x. Let's talk a little bit more about this graph. The graph of cosine is similar to the graph of sine, but there are some important key differences. Sine started at 0, 0 and increased from there. Cosine, on the other hand, starts its period at 0, 1 and decreases from there. So that's an important thing to remember. Sine starts its period at 0, 0 and increases. Cosine starts its period at 0, 1 and decreases. We will hit a 0 at pi over 2 and continue to decrease until we reach the minimum of negative 1 at pi. Then we will increase to another 0 at 3 pi over 2 and continue to increase back to the maximum of 1 at 2 pi. Just like sine, cosine is a cyclical function, meaning it will repeat itself over and over every 2 pi radians. That means that the period of cosine is also 2 pi, just like sine. The domain, which represents the allowable inputs for x into cosine, is all real numbers, or from negative infinity to infinity. This is the same as it was for sine. You can plug in any real number into cosine. The range, which represents the possible outputs for y, is between negative 1 and 1 inclusive. We can get anywhere from negative 1 all the way up to positive 1 as our output for cosine. The amplitude, which is how far the function travels from its center, called the midline, is just going to be 1, just like sine. We go 1 unit below the midline of the x-axis, and we go 1 unit above, so that means the amplitude is 1. To graph y equals cosine of x, we used a few important key points. We had 0, 1, we had pi over 2, 0, we have pi, negative 1, we have 3 pi over 2, 0, and we have 2 pi, 1. In addition to the key points, I would remember that cosine starts its period at a maximum and decreases from there. This contrasts it from sine, which starts at 0, 0 and increases from there. Alright, my friends, that completes my introduction to the graphs of sine and cosine. We will practice graphing translations of these graphs in the next few videos.